don't write it all. It doesn't matter to me. They're your notes. But it's going to ask you to express as a fraction in simplest form with a rational denominator. So, when you see these directions, simplest form right here means you must reduce. And what does rational denominator mean? What does it mean for us to have a rational denominator? Good. Let's see. It technically does not have to be a whole number. Technically, it wouldn't be in simplest form. You'd still need to reduce if you had like a decimal or fraction there. But rational, in particular, just means that it has to be a number of some sort that could be written as a fraction. Usually it's going to be whole numbers for us. It means that we can not have or we got no square root in the denominator. And what that's going to look like is basically we got to have a whole number for what we're going to be doing. Now, I am not sure who decided that you should have to rationalize denominators. It was not me, but somewhere along the line, all writers of pre-calculus textbooks and material have decided that you should have to rationalize a denominator, meaning you can't leave a square root in the bottom. You got to get rid of that square root from the bottom of the fraction. In reality, it's still not a rational number because you got a square root in the top, which means, what's rational mean? Rational number. The opposite would be an irrational number. Irrational numbers go on forever without a pattern. So like, for example, 0.3 repeating goes on forever, but it is equivalent to a fraction. It can be written as a fraction of 1/3. So it is a rational number, 0.3 repeating. But 0.17825439714 and so on is not a rational number because it just goes on forever. So things like pi, e, square roots that don't have perfect squares, those are going to give us irrational numbers. And so they don't want those in the bottom of a fraction. Whenever you take calculus, they don't care anymore. And you can leave square roots in the bottom of most answers. But all pre-calculus, pretty much this is like a main thing you need to do. There are some things in calculus where you still do need to rationalize, but it's a little bit different. So you guys already did, you don't have to write this one down, but you guys already did problems like number 7. All right, you don't have to write this down. I'm just going to run through it real quick because you've already done it. If you want to get rid of that square root in the bottom here and you just have a square root of 3, it's really simple because you're just going to multiply by the square root of 3 on the bottom and the square root of 3 on top. You are allowed to do that because what is square root of 3 divided by square root of 3? 1. And you can multiply anything by 1 because it just gives you what you started with, right? It doesn't change anything. So if I do this in the top, I get 5 square root of 3. In the bottom, square root of 3 times square root of 3, there's a few ways you can think about this. You can either think of it as square root of 9, which will give you 3, or you could think of it as square root of 3 squared, where the square root and the square cancel each other out, and you get the 3. A square root times that same square root is just going to give you whatever's under the square root there. So this would be rationalized because your denominator does not have a square root in it anymore. But for number 9, we cannot just multiply by the square root of 14. Because we have this 7 plus right here. So I'm going to do this. Don't write it down because it's wrong. Like if I tried to multiply this by the square root of 14 on top and bottom, the problem is that 14 would have to be multiplied by both of these things. So I would get 4 square root of 14 over here. I'd have to have 7 square root of 14 plus 14. It would get rid of this square root, but it would put 1 over here. So it would not get the square root out of the bottom completely. So we're going to have to use a different strategy whenever we see that we have something plus a square root here. So what we're going to have to do is called multiply by the conjugate. Okay, and the conjugate is whatever is going to give us a difference of squares. So it's pretty straightforward. If my denominator is 7 plus square root of 14, my conjugate is going to be 7 minus the square root of 14. And I'm going to have to multiply by that value on the top and bottom of that fraction. The difference of squares. Okay, so whenever I multiply this here, in the numerator, I just have 4 times the stuff in parentheses. So I could distribute that 4, and that is going to give me 28 minus 4 times the square root of 14. When I'm multiplying things together, and I have something on the outside of the square root and something on the inside of the square root, I cannot multiply those together. I just have, well, I can, but I can't put them like inside of the square root. They just have to be beside of each other. It's 4 times the square root of 14 is what we'll have here. So that's our numerator. In the denominator, I've got to distribute here, so I get 7 times 7, which is 49. I will get plus, no, I'm sorry, that's going to be minus. Minus 7 times the square root of 14. And then when I distribute that square root of 14, I'll get plus 7 times the square root of 14. And then I will have positive square root of 14 times negative square root of 14, which is going to give me negative 14. Okay, and so what's going to happen every single time is these two middle terms should cancel out. Okay, so these should cancel every time. Because the reason that we chose the conjugate 7 minus square root of 14 was so those middle terms would cancel out, because the middle terms are going to be the ones that have square roots with them, and we're trying to get rid of the square roots. So this is going to give me 28 minus 4 square root of 14 over, and I've got to do 49 minus 14, which is going to give me 35. Now, you want to look at this and see if anything will reduce. It is true that 28 and 35 are both divisible by 7, but we cannot reduce those two because we would have to divide every term by 7, and 7 will not go into 4 right here. I don't think there's anything else that will go into everything here, so we would just leave it for that. So this will just be our answer. So when you're looking to see if things will reduce, you have to look at every single term there. Okay, questions? All right, let's look at our next one. I promise they don't all have square root of 14s in them, but these two problems that I pulled did. Okay, directions are going to be the same on all of these, so you don't need to write those again, but you want to copy down that problem. And so we've got negative 2 over negative 9 minus the square root of 14. So my conjugate here is going to be, I'm only changing the middle sign, so it's negative 9 plus the square root of 14. You're just changing that middle sign. And if you multiply by that value on the bottom, you must also multiply by that value in the numerator as well. Because negative 9 plus square root of 14 over negative 9 plus square root of 14 equals 1. This doesn't change the value of the expression here. So like we did on the last problem, we're going to distribute that negative 2. That is going to give us positive 18 minus 2 square root of 14 for our numerator. For the denominator, we got to distribute here, and this is 2 binomials, so we got to distribute twice. Negative 9 times negative 9 gives us 81. Negative 9 times square root of 14 is a minus 9 square root of 14. Negative square root of 14 times negative 9 gives me a positive 9 square root of 14. And then negative square root of 14 times positive square root of 14 is going to give me negative 14. So what happens there in the denominator? I got a negative 9 root 14 and a positive 9 root 14. Those should cancel out every time. So you'll see on the next problem, I'm not going to write them anymore. I'm just going to do that part in my head and say, oh yeah, these cancel, to save myself a few steps there. So we are going to get 18 minus 2 square root of 14 over, and let's see, 81 minus 14 is going to be 67. And we want to see if this will reduce, but 18, 2, and 67, they do not have a common factor. You can't reduce those. All right, questions here? All right, here's one that's a little more complicated. All right, so does anybody see anything there that I could break down? You cannot take a 2 out of all of them because the fact that they're inside of the square root. So that will not work for this. There is, though, one of these square roots that we could break, like we could simplify the square root itself. It is not 10, like 10, you could make it 5 and 2, but or either one of those is a perfect square. No, you don't anywhere. It is 8, right? So we're going to have to deal with that 8 at some point. You could break it down now, or you can break it down later, but we don't want to leave that square root of 8 in our answer. So right now, I am just going to make myself a note. Do not leave square root of 8. But I think it's going to be a little bit easier to do the problem if I wait till the end to deal with it. So we're going to use the same strategy that we used on the other problems. We need to multiply by the conjugate. So that is going to be square root of 10 minus square root of 8. And we must also multiply by square root of 10 minus square root of 8 in the numerator. So this time we've got to distribute twice in the numerator and denominator. So when we're multiplying square root of 2 times square root of 10, both of those values are underneath the square root. So that's going to give us square root of 20. We're going to multiply those numbers together. And then we'll do square root of 2 times square root of 8, which is going to give me negative square root of 16. If you wanted to, you could go ahead and change that to 4. I'm going to do it on the next step, just so everybody's with me. Here, I've got square root of 10 times square root of 10, which is going to give me square root of 100, or if I wanted to there, I could go ahead and make that a 10. It's going to be a 10. And I got square root of 10 times square root of 8, so I got minus square root of 8. Now, in the denominator, I'm going to do something a little bit different. Well, I mean, I'm doing the same thing. But square root of 10 times square root of 10 is going to give me 10. Square root of 100, that is 10, right? Then, I said I was going to quit doing the middle terms for this because square root of 10 times square root of negative square root of 8 is going to give me negative square root of 80. But when I do this part, it's going to be positive square root of 80. Because of the conjugate, those middle terms should cancel out every time. So I'm just not going to write them. But if you want to, you can write them. But I'm not going to. And then I've got to multiply square root of 8 times negative square root of 8, and that is going to give me minus 8. So, in that numerator, we want to break down all of these square roots. Because right now I can't combine those. You can't add and subtract square roots. You can't say like square root of 4 plus square root of 9 equals square root of 13. That is not right. So you can't add and subtract things that are inside square roots. You can multiply them, but you cannot add and subtract. So, square root of 20, I could break it down. What could I break it into? 4 and 5, which would give me 2 square root of 5. So square root of 20, I'm going to make it 2 square root of 5. What is the square root of 16? 4. No square root is needed there because it's a perfect square. What's the square root of 100? 10. 80, what could I break that into? Four and 20 will work, but there's going to be a bigger one. If 4 works, you want to try 16. 16 might work. I think it does. 16 and 5 is 80. So that is going to be 5 square root of 5. Oh, good question. 4 square root of 5. This will all be over. I'm going to go ahead and subtract there. We'll get this all over too.
So then on your numerator, would it be plus 6?
Okay, I'll get a 6. And can I combine anything else? If I have a 2 square root of 5 and a negative 4 square root of 5, those are like having a 2x and a negative 4x. We can combine those. Yes. Uh-huh. No, it would be negative square root of, on the bottom, it's going to be 64. You're not adding those 8s, you're multiplying. Yeah. Okay. All right, we are almost done. And this is what's going to get a lot of you guys whenever you get to the assignment. It's like, this feels like you're done, but you're not. Because you always want to look at these numbers right here and see if you can reduce them. Is there something that will go into all 3 of those numbers? 2, right? So we can reduce this one. So that is going to be 3 minus 1 square root of 5 over 1. However, Delta Math might take that, but it looks prettier if you just do 3 minus square root of 5. You don't need 1s as denominators. You don't need 1s as coefficients either. And so this would be the best way to write your answer. Now, I also want to point out a very good way to, this does not guarantee you simplified it perfectly, but it will let you know if you made a mistake. So if I go back up here and I do my original square root of 2 plus square root of 10 over square root of 10 plus square root of 8. It is going to give me a decimal, right? So square root of 2 plus square root of 10 divided by square root of 10 plus square root of 8. So my answer should give me that same decimal because I am changing what my answer looks like, but it should still have that same value. So if I type in 3 minus square root of 5, please tell me it has the same value, and you can see it does. So that will at least let you know if you've made an error. What it will not do is it will not let you know if you have not reduced it far enough. Because if you look right here, if I typed in 6 minus 2 square root of 5 divided by 2, I'll get that same decimal. So, you know, that's not reduced far enough, so you wouldn't get the answer right because it is not reduced completely, even though it is still equivalent. So typing it in doesn't guarantee you got the right answer, but if you made a mistake, like if you had 3 plus square root of 5, it would help you catch that mistake because that would not give you the same decimal, and that would make you realize, oh yeah, something went wrong. I need to go back and figure out what I did incorrectly there. Okay, questions on that? All right, here's another one. Same instructions. This will be our last one. So we got 5 minus square root of 5 over 7 plus square root of 5. So we got to multiply by 7 minus the square root of 5 in the denominator. And if we do that, we must also multiply the numerator by that same value. So in the numerator, we're going to distribute here. We'll get 35 minus 5 square root of 5. Then we got to distribute here. We'll get minus 7 square root of 5. And then we got to do negative square root of 5 times negative square root of 5 is just going to give us a positive 5. And then for our denominator, we're going to have 49. When we do this outside term and these inside terms, we're getting a positive square root of 5 and a negative square root of 5. Positive 7 square root of 5 and a negative 7 square root of 5. And those are going to cancel each other out. That'll happen every time if you chose the conjugate correctly. So I really only have to look at multiplying those last two terms together. Square root of 5 and negative square root of 5 is going to give me negative 5. And so all we need to do now is combine our like terms and see if anything will reduce. 35 and 5 is going to be 40. And then I'll get negative 12 square root of 5. And 49 minus 5 is going to give me 44. And I'm looking to see if this will reduce. I'm looking at these three numbers here. It's got to be all three of them, not just one of them. And so what would go into all three of those? 4. So if I divide all these numbers by 4, we will get 10 minus 3 square root of 5 over 11. And that would be our answer. Okay, questions?